Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from differentiation involving the absolute value function, right? And here the problem which we are going to solve is a very useful problem for the beginners, right? So let us start. Now see, here we are given a function which is mod of x minus 2, right? And moreover, we are given a second function g of x, which is given as f of x. That is, this function g of x is the composition of f with f itself, right? So f of f can also be written as f composition f, and here we have x, right? So now here we have to find the derivative of this function g of x for x greater than 10 when g of x is given as a composition of f with f itself, right? So what we will do here, we'll first express the function g of x in terms of x, right? So now see, here g of x can be written as f of x, and see, here f of x is mod of x minus 2, right? So f of x can be written as mod of f of x minus 2, right? So f of x can be calculated by taking here f of x in place of x, right? So now g of x is equal to f of x minus 2, right? Now f of x can be replaced by a mod of x minus 2, and here we have minus 2, right? So the form of this function g of x is equal to mod of x minus 2 minus 2, right? So now we'll simplify this function g of x by making use of the definition of absolute value function. Now see, mod of p is defined as positive p whenever p is greater than 0, right? And mod of p is equal to 0 whenever p is equal to 0, and mod of p is negative of p whenever p is less than 0, right? Now see, here we have this mod of x minus 2, right? So mod of x minus 2 takes the value positive x minus 2 whenever x minus 2 is greater than 0, right? It means when x is greater than 2, right? And mod of x minus 2 is 0 whenever x minus 2 is equal to 0. It means x is equal to 2, right? And mod of x minus 2 is negative of x minus 2 whenever x minus 2 is less than 0. It means when x is less than 2, right? Now see, here we have x greater than 10, right? And here mod of x minus 2 is equal to positive x minus 2 when x is greater than 2, right? So what we will do here, we'll take this definition of mod of x minus 2, right? Because all values of x which are greater than 10, it would make x minus 2 a positive quantity, right? Because see, for example, if we take x is equal to 11, so x minus 2, that is 11 minus 2 is 9, which is a positive quantity, right? So mod of x minus 2 may be replaced by positive x minus 2, right? So here we have positive x minus 2, and here we have minus 2. So now we can simplify it. So we have mod of x minus 4, right? And again, we can see that mod of x minus 4 can be written as positive x minus 4 whenever x minus 4 is greater than 0. It means x is greater than 4, right? And here we have x greater than 10, right? So whenever x is greater than 10, then this quantity mod of x minus 4 should be equal to positive x minus 4, right? So we can now write positive x minus 4 whenever x is greater than 10. So the function g of x finally takes this form, right? So g of x is equal to x minus 4. Now if we differentiate both sides with respect to x, then the derivative of x minus 4 is equal to 1 minus 0, because the derivative of x is 1 and derivative of 4 is 0. This is equal to 1 minus 0 is equal to 1, right? So viewers, the derivative of g of x with respect to x for x greater than 10 is equal to 1, right? So d by dx of g of x is equal to 1 for all x greater than 10, right? So this is how by making use of the concept of absolute value function, we can solve these type of problems.